Hello friends, welcome to engineering tutorial. So we'll continue our discussion on thermodynamics. So in this video, we are going to discuss about thermal conduction. So before discussing it in detail, we will quickly review some of the earlier basic concepts related to, heat, temperature and heat conduction. So we know that heat is a form of energy which is basically the internal energy of a system, a body or an object, which produces in us the sensation of hotness or coolness. And basically the internal energy of a system in motion, in transit from one place to another place, that is called as heat. And this internal energy transfer, it happens only when there is a temperature difference between two objects or two bodies. Okay, so this is the basic concept. Okay, and there are two main theories related to heat, which is the caloric theory of heat and the dynamic theory of heat. Out of this, the dynamic theory of heat is more accepted. I mean, this is the accepted version, and according to this, all substances, solids, liquids and gases, they are made of molecules, atoms and molecules, which are always in a state of continuous random motion. And this motion of the molecules, it can be divided into three categories. Okay, translatory motion, which is the motion of the molecules along any straight line. Basically the three coordinate axes, they are taken as reference, x, y and z, but it can happen along any straight line motion, that is called as translatory motion. Then we have rotatory motion, which is rotation about any fixed axis from one point to another. Okay, and then we have vibrational motion. Okay, vibratory motion and vibrational motion, where it is the to and fro motion of the molecules about any central or mean position between any two extreme points. Okay, so there we have translatory motion, rotatory motion and oscillatory or vibratory motion. Now the sum total of these three motions, that gives us the average kinetic energy of the molecule, and the sum total of these three kinetic energies, because of the translational, rotational and vibrational motion, that contributes to the total internal energy of the object. So where this comes into play in our discussion related to thermal conduction. So we have discussed that heat is transferred whenever there is a temperature difference. But how is the heat transferred? What is the mechanism or mode of heat transfer? So there are three main mechanisms, three main modes in which transfer of heat takes place from one point to another. First is conduction, thermal conduction, which we will be discussing today. Then there are other two mechanisms, that is convection and radiation, which we will discuss separately. So today we will be discussing about thermal conduction. So thermal conduction is a process in which heat is transmitted from one part of a body which is at a higher temperature to another part which is at a lower temperature through continuous molecular collisions. Okay, and here no actual flow of matter it takes place. Okay, so here the important thing to note is that the temperature, the heat transfer, it takes place from one part which is at a higher temperature to another part which is at a lower temperature. So the temperature difference, it comes into play. So let us say we have a metal rod. Okay, we'll try to understand this. We have a metal rod. So it consists of molecules, okay, and these molecules have the three energies: translational, rotational and vibrational, which we have discussed. And these three energies, they come into play. The kinetic energies, the three kinetic energies, they come into play. So let us say one end of this metal rod that is heated. So the one end, it starts getting heated, and as a result of that, the molecules at the hot end, they vibrate with higher amplitude. Their net kinetic energy, that is translational, rotational and vibrational, all of them, they increase, and the average kinetic energy, it increases, and the amplitude of oscillation of these molecules, it starts increasing. As a result of increased oscillations or increased amplitude of oscillation, they collide with the neighboring molecules, adjacent molecules, and as a result of this collision, they impart, or a portion of their energy is transferred to the neighboring molecules. Okay, and as a result of this energy transfer, the neighboring molecules, they also start vibrating with an increased level, okay, increased amplitude, and their average kinetic energy, which is the sum total of rotational, translational and vibrational kinetic energy, that also increases. So they start vibrating with higher amplitude, and again they collide with their next adjacent or neighboring molecules, layer of molecules. So in this way, one end of the rod, when it is heated, it results in increased average kinetic energy of that layer of molecules. Their amplitude of vibration, it increases, they collide with the neighboring molecules, leading to increase in their energy. As a result, the rod slowly gets heated, and then these molecules, they collide with these neighboring adjacent molecules, and that results in their increase of energy, and they also start vibrating or oscillating with increased amplitude, and as a result, slowly the rod gets completely heated. Okay, the heat energy, it starts from this end, okay, it starts from one end and slowly it progresses from one end to the other, and it is all through transfer of the total kinetic energy, which is the sum total of translational, rotational and vibrational kinetic energy. So we all know, when an object is heated, it vibrates with higher amplitude, as a result of which the average kinetic energy, the total vibrational, translational and rotational kinetic energy, it increases, and as they undergo collision with neighboring molecules, they transfer some portion of their kinetic energy to the neighboring molecules, leading to an increase in their kinetic energy as well. And this process, it goes on and on and on and on till the entire rod, it gets heated. Okay, so this is the mechanism of thermal conduction. Okay, so here this concept of the dynamic theory of heat, which is all substances which are made of molecules which are in a state of random motion, and their translatory, rotatory and vibratory motion, and their relation with heat, that comes into play. Okay, so this heat as an energy of molecular motion, which is the sum total of these three energies, that comes into play. Okay, so this is the important point. Whenever a body or an object is heated, all these molecular motions, they become fast, and the kinetic energy of each molecule, due to each type of motion, it increases. Okay, that is what happens when one end of the rod is heated. All the energies, kinetic energies, that is rotational, translational and vibrational of one end increases, then it collides with the neighboring molecules, energy transfer takes place, then that portion also has increased energy, it collides with the next adjacent layer, their energy also increases, and like this the entire rod gets heated. Okay, so this is the basic concepts related to thermal conduction, that is mechanism of thermal conduction. In the next videos we'll be discussing in detail about the other aspects of thermal conduction. Okay, so this is just a basic introduction to the basic mechanism of thermal conduction. Okay, so I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.